proton of mass 1.67 times 10 to the minus 27 kilograms that has a charge of 1.6 times 10 to the negative 19 coulombs moves from point A to point B under the influence of an electrostatic force only. At point A, it moves at 50 kilometers per second. At point B, 80 kilometers per second. Neglect gravity and determine the potential difference VB minus VA. So let's just have everything written out. You can do this yourself. Just write out everything that you know. So we know that the mass here is in kilograms, which is good. That's our SI unit of mass. We have the charge, which is in coulombs, also good. Then we have our velocities, which are in kilometers per second, which that's not good. We want that in meters per second. We can do that now or later. Now it's also important to see that these V's are not the same as this delta V. These are our velocities. This is our change in potential. So here's another equation you should be familiar with. The change in kinetic energy is equal to the negative change of potential energy. And when we're dealing with electromagnetism, the change in potential energy is the charge times the change in potential. So let's put all this together and see what we get. So delta K is 1/2 m VB squared minus VA squared is equal to negative Q delta V. This delta V is what we are trying to figure out. This is our potential difference, so we want to isolate it, meaning we're going to divide each side by Q. So let's put in all of our values. We have 1/2 mass, which is 1.67 E minus 27. The E is just times 10 to the, so it's times 10 to the minus 27. Now, VB squared, so that's 80 squared minus 50 squared. And remember I said we're going to have to deal with this kilometers. We're going to have to do times 10 to the 6 to change those kilometers into meters. And then we have divided by Q, which is 1.6 E negative 19. I'm going to use my calculator because there's no way I'm doing that in my head. And you can just do that with me as well. Okay, so my delta V is equal to 20.35 volts. But here there's one thing I forgot, because we have a negative here. This should be a negative Q, which means this change in potential is negative. So our answer is about negative 20 volts.